Right, well, this should have been done a few sets back, but it's still within our 28-day turnaround. I think it's been in about 7 days now. And this is Gentleman's TRC1005. So these were £139.99 in 1983, and this is exactly the same chassis as the TRC1001, but you gain the digital display. The fact it says 4 watts on it, it is a 3.5 watt radio. But if we look at the service manual, if we look at the service manual, let's see what it says. So it is a 3.5 watt radio, and it's 3 to 4 watts. So if the radio is doing 4 watts, then fair enough. But if the radio is doing 3 watts, also fair enough. Crystal filtered as factory standard, not as sensitive as some sets, but that doesn't seem to make any difference. And we've had excellent range on these. The 1001 with the LED display, its predecessor from 1981, which was £119.99, is exactly the same chassis, but has the LED display instead of the LCD. The LCDs can be problematic on its subboard with dry joints. These sets and the 1001 suffer from dry joints, and invariably they're going to be under a shield plate, so you've got a lot of dismantling to do. So this is the customer's set, and what does he say? Hello Richard, please find enclosed one TRC 1005. Receive audio is intermittent, no transmit, and I think a segment of the LCD is not working. Well, if that's the case, there's nothing's going to happen there, but it could be a dry joint. So I'll put that to one side. Let's just make... did he put the serial number on this? No. Now then, we're going to do that, because when I take that other one out of its nappy, we're not going to know which one's which, possibly. Because this one sent in is in excellent condition. So, it is 459382, and we'll be doing this first. So it's in lovely condition. It's got a nice rattle in it, and the battery compartment, there's no corrosion. So one of the secrets of the excellent range of this, and the realistic 1001, and the little, well, I would say little, the 1.5 watt 2-channel big set like this, they have these range boost side panels, and a lot of people thought it was some kind of sales gimmick. It is not. These are connected to chassis. The fact that you've got your hand through that strap and you're holding those makes a huge difference to the range. And we're talking, you know, like 30% more range. So a lot of the handhelds, even with big long telescopic aerials, on our range tests on the difficult terrain, they will run out of steam at Wilsford level crossing. Same with the rubber duck sets, like the better rubber duck sets, like the President Randy 3. They'll work as far as there. But these sets will double that range simply by having a well-matched aerial and the range boost side panels. And people in another country will realise that the American had an AM FCC approved version with a beautiful centre-loaded aerial. You have to appreciate that at that time the UK wasn't allowed centre-loaded aerials. That was relaxed about 1987, and so when the realistic 1010 came out for CEPT band only, it did have the lovely centre-loaded telescopic aerial. So, you know, yeah, it would have been better, but there you go. That's how it is. Now this one, and this is why I've delayed the customer's repair a little bit. This is a eBay purchase, and I think one of our regulars, David Quotagious, I think that he said to me, hey look, there is a realistic TRC1005 on eBay right now for... That's the wrong picture. Oh, that's not the right one. What we're looking at. I just printed that off and I've now already lost it. So, this is the original listing, £20 including postage, and you know, I mean, surely a full-length telescopic aerial's got to be worth that. So it's come with its carrying case, and that's of course protected the radio to some extent. So I'll put that on one side for now. So that's my one. Battery contacts in just as good a condition, and the serial number on mine, when I get it the right way up, 492730. So mine's actually later. What does he say? Not working in a faulty condition, that's fine. So, we'll put mine to one side, and I'm not going to do it strap up, and then we'll know it. That's another reason we'll know it's mine. So we'll start by opening the customer's one up. And for those of you who don't know these sets, you've got an external mic socket which is 5-pin DIN for the standard mics which Tandy did at the time. It's a locking type 5-pin DIN. So when we make up a mic for it not using locking plug, not that it matters, I can't say I've ever pulled one out. And you've got high-low power, which is, of course is going to be somewhere between 3.5 and 4 watts on high power, and supposed to be 0.4 watts on low power. You've got an RCA phono for the antenna, and then the charger socket is expecting, the proprietary charger was something like 18 volts at 50 milliamps. Now back then rechargeable batteries were 500 milliamps, so it's 10% of the rechargeable battery charge current for 16 hours. So if you, these days with the higher capacity batteries, if you can actually get them to fit, because it seems to have got fatter these days, you'd probably be best off charging them internally. So what I'm trying to tell you is there's no internal charger circuit. It's up to the charger to provide the 50 milliamps. It is about 18 volts. And when that's applied, it doesn't allow the radio to be turned on. And then the external power socket is, I recall, it's positive inner, and we will just have to verify that. And the other thing we're going to do is what is the power input for the voltage. It's 12.5 volts. So yeah, I've remembered now. Yes, they sold, Tandy's sold a cigarette lighter adapter at the time for about $12.99, which dropped your 13.8 volt when the engine's running voltage in the car to 12.5 volts to run this radio. It is not a 13.8 volt radio, and the radio can be destroyed at that voltage level. So as ever with these type of things, it's 10 rechargeable batteries, so 10 times 1.2 volts equals 12, or it's 8 AA throwaway batteries like alkaline, because 12 times 1.5 also comes to, did I say 12? 8 times 1.5 volts also is 12, so that's 12 volts. So if you're using throwaway batteries, you insert 2 dummy batteries which are readily available on eBay. If they're sometimes called false batteries, if you have not got them with the set. It is important that, because what you don't want to be doing is killing the audio IC, which has been unobtainable for 2 decades, which can happen. And we've got a scrap one. I bought it as a scrap chassis because we could have probably fixed it, and of course all that's been destroyed by whoever, you know, another dealer's obviously scrapped it, and we bought it in like that. So that's your preamble on the way these work. So I'm expecting both these sets to have got at least one dry joint, causing the malfunction. So what we'll do is to open up the first screw. So we've got a long screw goes through the back. It even comes out. We've got one screw underneath, and that enables you to pop the lid off. I'll put the soldering iron on because I think we're going to need to be unsoldering the speaker. It's a bit tight. And you've got a very high quality build. Although it's SRBP printed circuit, which straight away puts it into a consumer type item, it's double-sided, but the letdown is it's not plated through in gold, and it relies on the pins of components or tinned copper pins sold at both sides to make that contact. And these started to play up with dry joints after, well, only about a year. But if you go through them and you desolder things and you resolder things, you know, it can be quite reliable. So I think what we'll do is we'll power this up. Is that a suitable? It is. Where does that go? We'll connect that up to our famous crocodile clips, just so we can spend the day shorting them together. We will have a Bofung 888 on ham radio. It's a little, what are they, 1/2 watt, 2 watt handheld. We're going to be doing a test on the bench, not opening it up, no point doing that. We're going to do a test on the bench to see what it says it does and what it does do. And then we're going to do a on the air test and a field test. So they're very, very cheap UHF hand portable from Baofeng. I think they're about £15 with charger and everything. So. I'm not sure I like whatever it is dangling inside. So I'm setting the power supply for 12.5 volts as it says in the service manual. So we'll power the thing up. So there's a segment out on the customers on the, and that's going to be, you just don't know, do you? It could be the display itself, it could be anything. If we try and put that into transmit, it is actually transmitting, so I better put an aerial in. So I think in the rattle and that of postage it's actually started working, which is always inconvenient when you're wanting to demonstrate something that isn't working. So if I find our RCA adapter, I'm just going to rattle my brain where we last had it. I'll pause the video while I think about that. So I looked in the van, because those Heathkit radios we have use RCA connectors. And then while I was outside, I took that Midland 77806D to the post office. We normally use Hermes, but this customer specifically asked me to do the post office. Now the local post office doesn't open every day, so I think he condescends to open Tuesdays, Wednesdays and Fridays. Oh, and a little bit of Saturday morning from about 9 to 10:30. Right, so we'll plug it in. I'll put picture in picture on. And can I see that? No, because I want it there. So although it's showing RF out, let's put this on channel 20. It's arrived on channel 31. Perhaps he was trying to call me on it. Testing 1 2, testing 1 2. So it's receiving and it's transmitting from just its works. It's not actually transmitting out of the aerial socket. So we could have a duff PA there, but then it could be dry joints. Okay, so that's done an exploration, hasn't it? So I'll unsolder this speaker, which looks like it's been unsoldered many times before. I'll switch it off and we'll look underneath. So this time it's the 4 screws in the range boost side panels which are countersunk. Now I didn't say it was easy to get this out. What on earth's happened here? It's like it's been rubbed with a duster. Perhaps it's been soaked in water and at some time in its life and somebody got the towel to it. I'm going to unsolder the battery box. There we go. Put that to one side as well. It's now just got the bare chassis. So the chances are, we will just try it again, but the chances are that the output transistor has been killed. So to get to that, we've got to take this shield plate off. I think these are fitted before the printed circuit's put in the metal chassis. So now we can clean up that later when we're ready to put it back. We're going to go around this from dry joints at the same time because they are prone to that. So the object was to get to the back of the output transistor so we can get the Russian meter on it. Right, we'll connect it up to power. Connect it up to the aerial just in case. By aerial I mean the test instruments. Switch on. Right. The clever bit now is locating where the transistor is. It's there. Nothing. 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 Interesting. So let's look at the driver. There's the driver, just there. So next to that can, I think we can only get to one leg because of the screen plates. Nothing. Right, this is where we get the service manual. Check there's a voltage on that transistor, the output transistor. So we're looking at here, and we're looking to see whether we've got power on the emitter with an ordinary voltmeter, because we've got nothing on anything. That's the driver I've tried to look at. So clearly one goes down to chassis, which is the emitter. You've got the RF going in on the base, and you've got the RF will be coming out on the collector, but the voltage rail is the collector. Stack another instrument on top. I think we'll connect the negative to the crocodile clip lead, so it's not constantly falling off the chassis. Put that round the back. So are we still switched on? We are. Let's just check we've got power. That didn't work, did it? It's already... If I was on Mr. Cho, we've got one of Mr. Chippy's crocodile clip leads here. We'll do that onto the earth instead. So there we go, 12.4 volts. So we do know we're connected. So now if we go back to the transistor, have we got anything? And we have. We've got 12 point. We have got the rail voltage there. Now I still can't get to that driver transistor. We haven't. But we've got power there as well. So it just, we know the thing's transmitting internally, so we know all the early stages, we know the transmit's being generated, so we know that it's got to be around here that we've got no transmit. So I'll tell you what we're going to do. We're going to unsolder that output transistor, because if that was short circuit, it would stop all the RF coming out, wouldn't it? So I'll turn the power off. It's probably some numpties transmitted without the aerial fully up, like they do in movies. Right, that should be sufficiently unsoldered. Two screws hold the heatsink. And hopefully that will withdraw complete. There we go. So with the transistor tester, yep, so that says it's working. So I'm going to look for RF now with this removed, in case something's dragging it down. Well, we won't need to plug the aerial in now. So switch back on. So clearly the centre pin is collector. So with the Russian meter once again, well, that's going to be chassis, so that's going to be emitter, so this is going to be the base. So let's see what we've got. And the answer is we've got absolutely nothing. So now, nothing for it, we're going to have to take the telescopic aerial out, and the next shield plates will switch to power off. So you need to make sure you recover the star washer from the other side. And then it's going to pull downwards, because it's got a plastic sleeve on it which stops it going through that grommet. So now we've got the fun of taking this next shield plate out. I've got a soldered bit there. That's it. Bit of the glue from that bobbly thing, rubber thing. So power it back up again. So this time we're looking for the driver transistor legs. And it looks to be like those three there. So we've got nothing there. So shall we go backwards and see if we can find test point 5. shall we just look at that transistor there, which is going to be Q18. Oh, test point 5, I can see that. So that looks to be those 3 legs there. Nothing, nothing, nothing. So let's go back another stage. Transistor 17. That's going to be there. Yes. Something, nothing. Funny. We did have, and we haven't now. Oh yes, there it is. That's a very small amount. So you know what? Let's see if the voltages are on that transistor Q17. So we'll look at the voltage table in the service manual, because that doesn't look right. Come on, tell me there is one. Yep, it is. How frustrating. Okay, so unless the resistor 74 is open circuit, we should be getting power from this transmit rail. So we know we've got it. We know we've got the full rail voltage on the output transistor and the driver transistor, but on your lower in the part of the circuit transmit stages, it gets its transmit rail from transistor 8 up here. So is that rail disappeared? Well, if we can locate capacitor 94, 22 microfarads, that seems a very sensible point at which to see whether we've got. But conversely, we could look at transistor 8 emitter. Transistor 8 emitter is probably easier. Thinking about it. So transistor 8 is 2SC1959. Ah, now is that regulator IC on the receiver or is it on transmit? Or are there two of them? So we know receive's working, so no, that's fine. So we'll go back to our original idea of transistor 8. So it's B, emitter collector base, So transistor 8 is right down here. So this is base. My meter's timed out. So on transmit we get 12 volts, which is what we'd expect. Well, we'd expect less than that, but it's probably under no load condition. Can't quite tell which is emitter and collector, but we'll look at them both. So we've got full rail voltage all the time on that one. Press transmit, nothing happens. And we've got, that's definitely giving us the rail. I'll just bring that into camera, you can't quite see it. But look what we've got there. We've got a tin plated pin that goes through the board. So if that is dry joint, then we'd have no transmit. So let's look at that on the other side of the radio. So we'll just push that diode to one side, and we'll solder this side of the radio as well. Now then, will that have restored operation? That's clearly on the... Anyway, let's go back to that transistor. So we still have no power coming up to this transistor. So once again we'll check we've got it coming out there. We have. And theoretically it should find its way over to here. So in between there so there's our transistor 8. If resistor 74 was open circuit, then we'd still have no transmit and no power to transistor 17. So resistor 74, 100 ohms. Let's see if we can find that. Resistor 74, 100 ohms. Resistor 73, resistor 74. Let's find it on the bottom side. Resistor 74. So it should be those two pins there. So go back into transmit. We've got nothing. Into transmit. We've got nothing. So there's nothing, that power rail just isn't getting there. It's going to be a dry joint, isn't it? which is exactly what these sets do, but it's finding them. So between the output of transistor 8 right, I'll switch the power off. He's going to go between there and there. It's going to go absolutely backwards and forwards all over the place. So we've got, that looks a perfect joint there, but we'll resolder it. I'm just looking at things in the transmitter department, and the other side so we follow that track. That's there to there to there, goes to there. Check that one. Check that one. Check that one. So we've got one on this side. But none of these look dodgy. Right, we'll power it back up. See whether we've got that voltage back. Yes, we have. So between those various little pins, all which look perfectly soldered, which I've done both sides of, so I bet now I've got RF voltage ready to go to the output transistor. Whoa! That's it. Fixed. So I'll put my Russian meter away, but you see the trouble that you've got to go to. And it's not just prodding them from one side, it's prodding them from both sides. We'll have to find out what's wrong with that, of course. So we'll put this back. Sorry to accuse you. But at least we've been able to fault find without plugging the aerial in all the time. Okay, so the first thing of course we want to do is to put those screws back in and then solder it, because obviously if you solder it first and then it's not, the placement isn't precise, you're going to end up straining the joint and possibly breaking the printed circuit board. Of course there were 2 screws in that, but there aren't 2 screws on my bench now, which means one's gone for a walk. Yeah, glad it's a ceramic floor. It's going to be a long video. solder that back in. And plug the test instruments now into the area socket once again and switch on, and fingers crossed we've got RF. We've still got picture in picture on. Yeah, we have. There we go. So on the, we've got 3 watts. I'll come to this later. This can be dirty pins, it can be a dry joint, you know, there's a whole raft of things it can be. Right, so now we'll plug the speaker in. Bit dirty control there. I'll try and clean that, but they're kind of sealed tight. Well, he's only going to want to retune. It's not like it's been messed with. I know it's had repair work before, but I'm not going to have to do the VCO, which you've got to take that board out, and it's a faff. I think it's a matter of that, and that. But I'll just have to check. It must be 9 months since I last saw one. So there's the layout. Transmit alignment. So I'm saying 6, 7 and 8 and L5, 8 and 9. So let's just have a look. So it's 5, 6, 7, 8, 8 and 9. 5, 6, 7, 8, 8 and 9. L5 is that first. T6, 7, 8, 6, 7, 8, 8 and 9. No, it isn't T5, I'm lying. So that's what we're doing. So we're wanting to hope to get to 3.5 watts, because at the moment it's just under spec. So we do need to be able to improve that. Now on this version we've got a preset here. Just make sure that's at full. It wasn't. We're already doing 3.3 watts with that at full. We'll turn that down if we can. I don't think it's the green tool fits these. I think it's the white one. Let's just check. Yeah, that's as loose as anything. It's this white one. So that's in the Velleman VTPT1, which you end up having to import and costing a fortune. So it's... I've already forgotten what I've told you. So it's L5, which is that one. So that brings us to 3.5 watts. So that's at the factory bit where you'd expect it to be. And T6, 7 and 8. So 6, 7 and 8, 6, 7 and 8. I don't know if we're field testing this because... or mine, because we have done one of these before. Well, that was slightly out, 3.6 watts. And then we just need to do 8 and 9. That's peaked at 4. So it's just over the 4, what we're going to do is we'll just pop down that preset. The radio is not being thrashed. There we go, 4 watts. You don't always get that. I'm sure it's my coffee break. It is. So we'll just see where we are with the deviation. We usually have to turn these up to full, to be honest. So they say that they want you to turn that variable resistor to 3.5 watts. Well, we're going to keep it at 4, so the customer gets through his batteries quicker. Variable resistor 2, we've covered that. We just check high-low power. It isn't adjustable, we just check it. It's supposed to be 0.4, but it's between, as long as it's between 0.1 and 0.4. So here we go. It is 0.25. So put that back to high power. Now we're going to do the deviation with VR1. VR1 is the one just there. So we'll just check that. Well, check it with my whistle first. Wallow, 1 to wallow. It's 2.1, so it's probably about there. That's full. Let's just see where that brings us to. 1, 2, that's too high. One, two, wallow. That's it. Phew. Well, that's us all the transmit done. We'll just set the signal generator so as we've got something coming out of it. Don't think for a moment these have got a what's it meter, RX meter. So on transmit it is relative power. So on high power when we transmit with the proper voltage, you're going to expect all the bars. When we go into low power, you're going to get a couple of bars. That's as it is. On receive, that's a battery meter. That's all it is. So don't think for a moment it has an S meter. And you'll see if you get the contrast right, this bought-in display has got signal legend, but this radio does not use that. So don't think it's faulty. It does not have an RF meter. Sorry, an S meter. And that can be disappointing to people who like S meters, but I don't care an iota because I'm not into S meters. Right, we'll pause the video. Okay, so I've put the bottom shield plate on. I'm not going to put both on at this stage because if you get something wrong, we'll then know which one it is. If I get something wrong, I'll know which one it is. Right, let's power it back up. We'll check we've still got transmit. Yep, fine. Check we've still got transmitted audio. Wallow, fine. So now it's receive time. So we're going to start with the detector. I don't know what they tell you to do in the service manual, but we're going to start with the detector. I think we can fold that circuit diagram away. He does mention intermittent receive, and hopefully we've covered the right number of jar joints. I will have this on a 24-hour test before he gets it back. Right. So here we go. Now we're on receive. So transformer 4 is our detector. Transformer 4. That one. With an S9 signal, which we've got, we'll go over to the oscilloscope. And we'll just make sure we've got the maximum recovered audio. Yes, it was already spot on. So then it's transformer 1, 2, 3 and 4. So 1, 2, 3, 4. L12 is the 56-55 meg second harmonic trap. We're not touching it. 1, 2, 3, 4. 1, 2, 3. Am I right? 1, 2, 3. We've covered 4, haven't we? It's 1, 2, 3, 5. 1, 2, 3. 1, 2, 3, 5. Sorry about that. 1, 2, 3, 5. So we're going to drop the signal generator off and the squelch off. We'll go over to our Synad meter. And right now, let's have a look at what the sensitivity is. I get the gentleman's letter, which I've probably already lost. Of course I have. Ah, there it is. So TX when it came on was 3 watts, and RX was watt. So let's adjust yeah, it's just under 1 microvolt. One point 1.25 microvolt for 12 dB Synad. I think they have it in a different format. I'll just have a look before we change that. Sensitivity, it's 10 dB, and they'd like it to be less than 5, so we need to go to 10 dB to be in line with what the manual says, and it is, I think I can change scales now, 0.95. So 0.95 for 10 dB Synad, and that's in spec, because the service manual says your limit spec is 1 microvolt and the ideal spec is 0.5. So let's see if we can bring it up from that, and then I will check what the 12 is, because we tend to work on 12, and so does Radio Cruncher, and so does all the Gear No Idea. Well, it's industry standard, but these are all over the place, including using 20. So we'll drop that down to about 4, so we're not saturating the receiver. There's possibly a micro gain there. No gain there. Just going to check that at a higher level. No, it needs to be at the lower level. That's been messed with, hasn't it? Somebody has thought that's transmit with it being up there. So I'll just recheck that one. Yeah, that's it, we're done. So let's see what we've got now. So for 12 microvolts, and I'll go over to the attenuator now so you can see. We've got 1 microvolt there, and we've got 1 microvolt there, so it's exactly on the 1. But let's go to the bigger scale. So we're now on the 3 microvolt scale, and again it's 1. So it's 1 microvolt. As I say, they're not as sensitive as sunsets, but they're crystal filtered, and that often introduces less sensitivity. So, where are we for 10 dB? So we'll put that on there so you can see we're more or less on the 10, hovering around the 10. And let's look where we are on the attenuator now. So there's the 1, and there's the 8. So it's now 0.8 of a microvolt. So as it came, it was within the spec. It's now even more within the spec. So all we've got to do now, I think, is squelch. Just check. I don't remember whether it has squelch to adjust or not. It doesn't. They just want you to check squelch operation. So we're going to check squelch operation. So, as I've said a little before I do that, how far can we hear it down to? It's all right having how many decibels. Well, that's 0.3 of a microvolt. We can still hear it. I can hear it down to 0.12 of a microvolt. You know, so the only reason it's not so good with the Synad is because it introduces noise. That's looking for signal to noise ratio. So it's noisy with it. And that can be relatively cheap transistors used. At the end of the day, I know they were $139.99, but they weren't business radio quality, you know, like £600. So you've got to... It's like people with those Baofeng handhelds. Oh, they're rubbish, they are. Well, in comparison to what? You know, in comparison to a £500 radio, it probably... There you are. So, squelch. I'll put the signal generator to standby. We'll set the squelch to threshold. Switch the signal generator back on. Opening at 1.3 microvolts, closing at 0.7 microvolts. I'll just see if we can set it a bit finer than that. You can sometimes. Shouldn't have to, but you know what I mean. So now, let's see what we've got. So now it's coming in at 0.9 of a microvolt and leaving it 0.49 of a microvolt. So it's alright. They're a bit clunky, these squelchers. They hover in and out going clickety clickety click, so they can be annoying. So let's we'll crank up this squelch to full, and as ever I'd like it to not come in until S9, which is 100 microvolts, so that's 3 microvolts, 10, comes in at 10. You know, so it's not ideal, it's not adjustable, but that's only going to play up if you're using it as a base station. So next I'm going to put it together. So next time when you see this, it'll be all put together and we'll put it on the aerial. Right, we're put back together. I did take the display out and clean the pins. I'm not going further than that. It's unimportant. I'm not going to start unsoldering displays. It's not going to be possible to replace it if it's faulty. It doesn't look like it's been in a nicotine environment, but that would be something that would be harmful to a display like that. Pop that back onto, just check it's working. Transmit, while at 1, 2, transmitted audio, and receive. Right, so now we'll put the roof aerial on instead of the test instruments. So I'm going to do another video straight after this one on repairing my one. So those of you who are interested, see what was wrong with the one I bought off eBay for 20 quid delivered. Hope it's easier than this one. One niner Roger. Most of the people here are 35 miles away. "19 a Roger." Right, we'll leave it at that then. We'll turn the squelch up as well. So I hope you enjoyed that exploration of the realistic TRC1005 from the customer. That was a genuine fault. We don't actually know which through board link was the faulty one, because I went through them all, and we're going to do a on the air test with this. I don't think we're going to be doing a field test. We don't need to. We know they do 6 miles, and then we'll do the same with ours probably another day. What was I going to say? Yeah, we've also got Stereo Master 2411 just about finished, and just got one capacitor to do on that for those of you into the vintage audio things. So next video will be another one of these, so you can skip it if you're bored with them. But I have gone through this for those people who want to know what happens to these. And it is always dry joints, and they're always under those screen plates. Thanks for watching.